This question caused me some problems. I think one of the hardest on the paper, that you got to work through logically and realize certain things, certain facts to use, which I'm going to explain here. So here's my square-based pyramid, and I'm going to label it A, B, C, D, E. Now we're using the numbers 1, 2, 3, 4, 5, but we don't know where they go. And I wouldn't advise trial and error, trying to stick certain ones at the top. It's just, there's going to be, you might get lucky, but you might just end up spending a lot of time not getting anywhere. So we're always trying to work through logically what's going on. Now we're told that four of the sums are 7, 8, 9, and 10. So it's worth just thinking about how might be able to get each of these, especially the smallest one. So to get the smallest one, we could do 1, 2, and 4. And actually, I should probably write it as 1 plus 2 plus 4 is 7. But here's the thing, if you try and do something else, like 1 plus 3, immediately we can't make it work, or 2 plus 3. So basically, it must be 1, 2, and 4 that gives us 7. And that means it must be one of the triangles, because we're getting sums from 5 faces, but 4 of them are triangles and one of them is a square. So this is a triangle 1, and 5, therefore, has to go on the square. It's going to be part of one of the triangles, but it's definitely not going to be at the top. So I'm just going to replace B by 5. I can do that without loss of generality, because I could imagine rotating the pyramid and so on. But I might come back to using B. I'm just going to stick it there for now. Now, what is the minimum that I could get from the, this is quite tricky to realize to do this, but what is the minimum I could get for the square when I add it up? Well, it would be 5, so min for square, because we've got quite a big number on the square now, is going to be 5 plus 1 plus 2 plus 3, which is 11, which means something very useful, and that is that 7, 8, 9, 10 are all going to be for the triangle faces, because they can't be the square, because we've just shown that the minimum for the square is 11. It's got to be 11 or more. It cannot be 7, 8, 9, or 10. So 7, 8, 9, and 10, that should say, are the triangle faces. And now in business, okay, and this, you could have assumed that and got away with it, but now we've actually shown it for sure. Right, so let's have a go at adding the triangle sums. We're going to get A, so if I do this triangle on the left, I'm going to get A plus E. I'm going to stick with B for the time being. I know I've set it equal to 5, but let's write it again in terms of B. Plus E plus B plus C for this front face, plus E plus D plus C for the right-hand face, plus the very back face, E plus A plus D. And we know that that has got to be 7 plus 8 plus 9 plus 10. All right. So remember, we're trying to work out the sum of the fifth face, which at this point we know is A plus B plus C plus D. That's what I'm trying to figure out. So sorting this out, we're going to have 2A plus 2B plus 2C plus 2D plus, and then I've actually got 1, 2, 3, 4 lots of E, but I'm going to write it as 2E plus 2E for reasons that I'll go into. And that's going to be 15 plus 19, it's going to be 34. Because I can write this now as 2A plus B plus C plus D plus E plus 2E is 34. And here's the thing, I know what A, B, C, D, E, well, I don't know what they are, but I know that they're 1, 2, 3, 4, 5 in some order. So this here has got to be 1 plus 2 plus 3 plus 4 plus 5. I can either quickly add that up, it's going to be 3, 6, it's going to be 15, or you can use the triangle number formula, a half times 5 times 6, a half times n plus 1. Probably just easiest in this case to add them up without, using that. Okay, so now I've got 30 is equal to 2e plus 34. And there we go. It must be that 2e is equal. Sorry, that should have been a. What have I just done? 30 plus. Okay, there we go. Sorry. 2e is equal to 4, and therefore e is equal to 2. I have shown using logic that the top number is actually 2. And how does that help? Because now I can just put the other ones in, and it must be that the sum of the fifth face, the one we haven't done, this square face here, is going to be 5 plus 4 plus 1 plus 3 is going to be 13. Whew, okay, well done if you got that. Awkward question, but I hope my logical reasoning makes sense.